So hello everyone, welcome to my channel. So from today onwards, I am going to start a binary search playlist in which we would solve binary search questions on LeetCode or on Take It Forward Plus platform. So firstly, we would understand that what is exactly binary search is. So there are maybe two searching algorithms. First is a linear search and second is the binary search. In a linear search, as we already know that if we want to target an element, we would traverse in the array element by element. But binary search is different from it. So I have written some pointers about it. First, we would understand what exactly binary search is. Then we would do a dry run on an array, and after that we would code it up. So the first pointer is that it is a fast searching algorithm. Now in linear search, we know that if we want to target an element, we would go element by which would take up a time complexity of bigger of n, even if the element is not present in the array. But binary search is different from it. We will see in the further onwards that how it is different from the linear search. So it is fast searching algorithm as compared to the linear search or other searching algorithms. Now it works on sorted array, the main pointer. Whenever we want to search a binary, whenever we want to apply a binary search on any array or any data structure to solve, the main pointer is that it is a very main pointer that we need to see that it always works on a sorted array. That the array needs to be sorted if we want to apply binary search. After that, it checks the middle element. Now, what is the main perspective of binary searches? The array is divided into two halves according to the middle element by applying a condition, and the middle element checks that if there are the element is equal to the target or not, it is in the right search space or the left search space. It reduces the search space by half each step. When we encounter a middle element, we check if our element is present in the right part of the middle or in the left part of the middle, according to which the search space get half or it get reduced. And the time complexity of binary search is bigger of log base 1. Log base 1 means the array is divided into two halves, and in each step the array is divided into half steps. So that is why we are saying that the time complexity log base 1. And the last one is space complexity, where the iterative solution is bigger of 1 but recursive is different. So now we will take an example of to see how a binary search exactly works. So there are mainly want to consider three pointers in mind, and we would firstly take here we would consider a low which is always pointing to the first element in the array. Nextly, we have a high pointer which is always pointing to the last element in the array. We would also give indexing to the array as zero based indexing. We would give it 0 and 1. So the low would always point to the first element in the array, and the high would always point to the last element in the array. Now we would calculate the mid. How would middle is calculated? Middle is calculated by using this formula as mid is equal to low plus high divided by 2. Now in the first step, the middle would be calculated as 0 plus 9, which is equal to 9, and divided by 2, which gives 4. So middle would point at the fourth index, which is 16. So mid would be here. Now we can consider the target element if we want to find it in the array. So we can consider the target element as 12. Now we would check that if this target element is lesser than 16, or it is greater than 16, or it is equal to 16. Now if let us suppose the target would be given as 16 and the middle element gets 16. So target get equals to lumps of mid, hence we return this middle index. Now here we can see that the middle element is greater than target. So we can say that the target would never be here in the right space because the middle element is as the array is sorted and the middle element is greater than the target, the right search space would be reduced or it would be eliminated. We can conclude that the target element would always be present in the left search space. So this is what we are going to do. Now the target, we would reduce our search space as I am showing to you. What we are going to do that we are going to move this high pointer. So we are going to move this high pointer at middle -1. So which can say that we are trimming our right search space to only one search space and we will place our high pointer here. Now again we are going to calculate our middle element. So now mid will be calculated as following. The low is given as 0 and the high is 3, which is equal to 3 divided by 2, which gives 1. Now the middle will be placed at the first index and we will place it here. Again we are going to check the same that if our middle element is equal to the target, it is lesser or it is greater. Now here we can see that the middle element is lesser than the target element, hence we can conclude that it will never be here in the left search space. So we are going to trim down the left search space. So we are going to place the low at mid +1 here. Now again we would check our middle, which would be equal to 2 plus 3, which gives 5 divided by 2, which is equal to 2, which means that at middle would be placed at here at the with the low. Again we would check that middle element is equal to, no, it is not equal to 12, which it is lesser than 12. So we are again going to trim our search space, means we would move the low at mid +1, which is here only. Now again we are going to check that what it is the middle now. So 3 plus 3, which gives 6 divided by 2, which gives 3, means the middle will also be placed here at the third index. Now we can see that the middle is equal to the target element. The target element was given 12 and the middle is also 12, so we can return the index. Now we are going to code this up quickly. So I have taken the inclusive library and after that I have included the namespace and I have taken a function on which I will write the code and taken the same array which I have used for the diagram and the target element which we are going to find in this array. So firstly we will calculate the size of the array as from dot size. We're going to take the low pointer which is at the first index and we are going to take the high pointer which is at the last element. Now we will take a while loop such that the low does not crosses the high, and in this while loop we are going to calculate the middle element which would be low plus high divided by 2. Now I have said three edge cases which should be encountered while when we calculate the middle element. First is when the middle element is equal to the target element. If this is the case, then we would return the mid index. Else, if the nums of mid is lesser than the target element, this means that the target element is present at the right, and we need to turn down the left search space, and else the last case in which we have to reduce the right search space. And if none of these occur means the element is not present in the array, then we can return a -1. So here we have taken the answer in the answer variable, and we will check that if the answer is equal to -1, we are going to say that the element is not present in the else we would say that so I have written the code and we are going to quickly run this up. So here the index is 3 means that the target element 12 is present at the third index. Now let us add such any target that it is not present in the array. Let us run this too. So say the element is not present in the array. So then this is what about binary all about binary search. Hope you have liked it.